Today I'm going to do a complete alignment on a Bitx kit, and we're going to use varying amounts of test equipment, but you should be able to do this same process with very little equipment, and I'll demonstrate the minimal way of doing it and some of the more advanced ways of making the adjustments. But the minimum pieces of equipment that you'll need will be a digital voltmeter. You'll need a dummy load or an antenna to connect to it, so when we transmit, we have the proper load on the transmitter. And one other thing we'll need will be a receiver with a frequency dial so that we can calibrate the VFO frequency. I'm also going to be using an RF probe and an oscilloscope in places just to show you how you do it if you had that equipment available to you. Let's get started. The very first step you probably want to do is adjust all the bias pots on the transmitter fully counterclockwise. There's 4 of them here. So that we make sure we don't harm anything while we're in the process of alignment. The next thing we want to check is the current draw, because that'll give us a fair indication of whether or not there's something major wrong or not. We're in a receive mode, and with my meter we're getting 122 milliamps in receive, and we'll switch to transmit and we're getting about 186 in transmit, and those are about nominal for the kit from what I've seen and heard. So if you're in this ballpark, you should be okay. If you're way low, that means you have something wrong somewhere in one of your stages, and about all I can suggest then is check collector voltages on your transistors, make sure everybody's turned on. That gets into the troubleshooting mode. This video is primarily concerned with alignment. So we've got our currents, so we're ready for the next step. If you're doing a minimal equipment alignment and don't have an oscilloscope, you'll have to assume that the BFO is working. That's probably a pretty good assumption because there's standardized parts and it's probably going to work just fine. But if you have an oscilloscope, a good place to check is right here. This junction here at the top of R67. We'll check and we'll take a look and see what voltage we have with the oscilloscope, and we can also check it with an RF probe while we're at it. We're going to make measurements using my Sharpie RF probe. The plans are on my website, so you take a look at kc0wox.com and you should find a link to the Sharpie RF probe. But with an RF probe, the values we get are not particularly important. What's more important is that you get some value, simply because there's a diode in here, so we have diode losses. We have non-sinusoidal waveforms give us different waveforms because the probe is going to do a peak measurement and then convert it to RMS voltage using math. So if it's not a sine wave, it gives us wrong answers. Diode conduction gives us varying voltages. But if you have a probe like this that has a DC blocking capacitor in series, if you measure any value at all, that means there's RF there. So we'll take a look and see what we find at our top end of R67. And it says we have 0.72 volts there. So let's go ahead and check it with the scope and we'll compare the readings. The 0.72 tells me I've got a fair amount of 11 megahertz signal at least. Looking at it with the scope, we have 2.5 volts of 11 megahertz. So that should be great. If you don't have quite that much, shouldn't be a big problem, but it should be somewhat close. Okay, how do you set the VFO frequency if you don't have a frequency counter, a scope, or any fancy equipment? The minimalist, boy, I'll have to learn how to pronounce it. The minimalist way is to do this. Start with the arrow pointing to the 9 o'clock position. That gives us the lowest frequency out of the BFO. And the highest frequency out of the BFO is going to be with the arrow pointed at the 3 o'clock position. In all my tape, I'm going to always start and turn the capacitor clockwise from the 9 o'clock position. It'll work going counterclockwise, but we've got to get a standard here. So we're going to always go clockwise from the 9 o'clock position. Hook up the air antenna or a long wire to your radio, so we're going to get some noise. Tune to a place where all you hear is just static like this. Now I'm going to adjust and listen to what happens to the frequency. It went down, it got deeper in frequency. And if I keep going, it'll increase again. That point right there is where we have the BFO frequency tuned to the center of the filter. So let's go back to the 9 o'clock position again. So I can tell the 9 o'clock position just by the sound. That's the 9 o'clock position, and if you look, there it is. So what we're going to do is we're going to adjust this. We're not going to go to that point. We don't want that point because that has the BFO centered in the filter. So we go back to 9 o'clock, and we're going to just decrease the sound a little bit. And that's where we're going to leave it. That may not be the perfect position, but what you can then do when you get your rig on the air, if your audio sounds too bassy, with too much bass, you need to go back counterclockwise a little bit to move the BFO frequency a little further away from the filter. If you're too trebly, that means you have the BFO frequency set too low, and you need to increase the frequency a little bit by going a little more clockwise. We're going to check the VFO voltage right here at the junction of R27 and Q6 collector. So we'll use our RF probe and we'll use the scope both, and we'll take a look. R27 you can't get to because the end we want to check is down on the board. So what we can check is right here. If you look at the circuit board, you can actually see the trace going over from the bottom end of R27 over into Q6. So that's where we'll check for our VFO voltage. Okay, our RF probe says we have 0.59 volts there. So let's take a look at it with the oscilloscope. Okay, our oscilloscope says we have about 1.5 volts there. And as we vary the tuning capacitor, it varies the frequency. So we should be good there. We're going to check the tuning frequency tuning range. First thing we want to do is take and adjust the carrier null adjust all the way to one end. And the reason why is we want to have it output a carrier. We're going to go to the transmit mode, and we just have a antenna laying down here across the board, and that's hooked down to a receiver. Okay, remember when you're doing this, we've got all our PA biases and drives all counterclockwise, so we're not really putting out much power, and that's just what we want. We want a low power. So I've got my tuning capacitor unmeshed all the way, which that puts me in the highest frequency mode. I'm going to just tune for a 0 beat. Once I find a 0 beat, I'm going to vary the tuning capacitor to make sure I don't have some birdie or something. So that's the top end of my tuning right now. So I'm going to drop down a little ways with my tuning capacitor. then I'm going to go look for it. Every time I find it, I'll verify that's it by tuning the tuning capacitor. Okay, we're still following it down. Still following it down. Still following down. Okay, what this is showing me is I'm tuned a little low with this, and I should make some component changes to increase it. Okay, that's as low as I can go with my receiver I'm testing it with. I'm testing it with my Far Circuits Bitx with a digital dial installed on it and a 10-turn pot for the frequency adjust. So let's go back up higher in frequency and find it again. Okay, we found it again. What I'm going to do now is show you why we adjusted the carrier balance pot all the way to one side. I'm going to adjust it again. There's with the carrier balance pot set in the center, which is about carrier null on this particular one. If I go all the way the other way, I get carrier again. So you can rough set the carrier balance pot at this time. Okay, I'm going to leave it there. So it's rough set, and we'll fine tune it when we get back down to the PA. Next, let's rough set C14 and C18 here on the input bandpass filter. Okay, we have an antenna hooked. We're in receive mode, and we're going to just listen to the noise change. We're just going to tune for maximum noise. So we go back and forth a little bit. And those should be rough set now. If everything's working, you should be able to hear signals. I don't have the fine-tuned Bracker pot hooked up on mine, so it's a little touchy on adjustment.
As a matter of fact, we got held over there in Chicago, I think it were, and son of a gun because of a problem with
Band's not doing too bad today. Boy, you'll wish for ALC here when they get a strong signal. I've looked at mine, and at the hot end of the volume control pot, I've seen signals as high as 1.2 volts of audio when they're really pound in like that one is. Okay, now we're all ready to light up the transmitter. got an amp meter in the series with the line, so I'm going to adjust my voltage up a little bit, about 13.5, because the amp meter is going to drop a little bit. That causes the current to increase a little bit, but that's not a big deal. So let's go to transmit mode, but before you do, make sure you have a load hooked up. You don't want to do this open circuit because you could really smoke something. So I've got my 50 ohm dummy load hooked up. I'm going to transmit. I have no input in the mic jack, so the procedure says to adjust R8 for an increase of 20 milliamps. So I'm going to go from 206. Actually, what I'm going to do is I'm going to drop the voltage just a little bit, because if I do, I can probably hit the 200 mark right on the. That's 201, and my supply is 13.2, so I'm going to adjust R8 for 20 more milliamps. Once it starts, it goes fast. That's close enough to 20 more. The next step, I have to adjust the IRF 510s. I'm going to add 50 milliamps, but I have to change, I'm going to change meters, because the meter, this meter only goes to 300 milliamps, and I'm going to have to go to 320 for the final. So I'm going to unkey it. The whole time you do this process, make sure you monitor the temperature on the heat sinks. They're not getting warm yet because they're not turned on. So let's change meters at one that got a little more range to it. We've adjusted the PA bias, so let's give it a little bit of drive. I'm going to give it about a half a volt of. I'm going to drop the tuner resistor. Let's take and set it about halfway. Let's go a quarter way. I'm a little more than a quarter. Now that we have some actual RF coming out, we can adjust the carrier balance pot that we adjusted just by listening to the noise level. Boy, and we had it pretty good. Because if I move it at all, there we have just 300 or 400 millivolts, and you just adjust it for a minimum amount there. It's pretty darn close. You can play with this for a little bit if you want. Try to get it smaller. I'm not going to worry about it right now. Let's adjust just a little bit of carrier back in it, because I want to do one thing. Before you adjust the carrier all the way out, adjust C18 and C14 for maximum signal, because it's real easy to do right at this point. Remember, we tweaked it just listening to the noise. We were pretty close, but not exact. If you don't have a scope, just tweaking it to the noise would be fine. Okay, so that's peaked. So now we'll go back and we'll readjust the carrier balance for minimum. Yeah, that's too sensitive a range. So I'm going to just leave it right there. Okay, now how do you set the drive level without an oscilloscope? First, we're going to show you how I get set up so that I can prove a couple things, and then we'll come back and we'll do it without an oscilloscope. In my case, I'm applying 25 millivolts. I've adjusted the drive level so I got 70 volts out, peak to peak. If you take the formula peak, which is 35 volts times 0.707, and square that and divide that by 50, you'll get 12.2 watts. So when I have 70 volts output, I have 12 watts of power out. We're back on the amp meter. This has been receive. I'm going to go to where I have 12 watts of power output. I read 1.94 amps. So what you should be able to do is, if your amp readings are about the same as mine, you should be able to hook up a microphone and give it a loud "ah" and adjust the drive level to where you get 1.97 or 2 amps, and that should have you in the real ballpark for the drive level. This is the first time a microphone's ever been hooked up to this. So I'm going to give it a long "ah." Ah. Ah. And it looks like it's going up to a little around 2 amps. So let's look at the scope while we do that. Okay, we're testing here now. Here's audio. Putting RF, and it's bouncing up to peaks up at 7-8 volts peak. So that's about what we want it. So we can adjust the drive level to get that. So I have a microphone that has a adjustable output, and it seems to be working fine. So I'm going to stick with that. The drive level pot's only a little over a quarter of the way up, and the audio didn't look too bad on the scope. So I'm going to have to try this on the air next. This particular board has never had a microphone hooked to it before. It's always been a signal generator. So we'll have to see how it sounds on the air next.
The bias of the father runs on through the son, leaving him bothered and bewildered. The drugs in his veins only cause him to spit at the face staring back in the mirror. How can he tell the good act from the bad? He can't even remember his name. How can he do what needs to be done when he's a follower and not a leader?